All right, so this is AP Calculus. It is Tuesday. I was practicing the AP Spanish test, which is why this is late. Let's go over number 3. This was from the AP test that you took this last Sunday. All right, so this is technically problem number. Yeah, this is problem number 3. So there's no calculators. I need to find this by hand. So this is going to be the line 2x. This is the line x squared. It seems like we've done this problem before.
We have done this problem before.
It's eerily familiar. Is it from a review packet?
Yeah,
Anyway,
from yesterday's review packet.
is this yesterday's review packet?
Yeah, because remember,
it is yesterday's review packet.
yeah, I can't even show you.
Okay, wait. So
That seems like it is.
we are on 3-2,
Was yesterday Monday?
and 3-2 is doing this
Oh my
type of
God.
problem.
So confused.
Weird. So it's doing the same type of problem. Okay, well, I'm just going to go over this one because I've literally done this problem already before. Let's do this problem. I guess we need more practice on finding the area between curves. This is a calculator problem, though. So does everyone have a calculator?
Oh, this is
We grabbed them already?
Yeah.
Rochelle.
Oh, it's fine.
Throw
Throw it.
Don't throw it, don't throw it.
It's like $100 hardware, which is sad because it shouldn't be $100, especially since you can get free emulators and such. All right, so let's find this area. Let's open up Mr. Sandell's calculator as well. Wabbit EMU, Open Recent, TI 83 Plus. All right, so we need to find the area R, which means we need to find the intersection points. It's pretty clear that's going to be 0 and 2, but let's go ahead and double check that by graphing it. Actually, can we do this by hand? If I plug in 2, it's going to be sine of 2 pi. Sine of 2 pi is the same thing as sine of 0. Sine of 0 is 0. Okay, if I plug in 2 here, I'm going to get 8 minus 8. Okay, yeah, my bounds are clearly 0 and 8. I just did that in my head, but you can check it on the calculator as well. I might as well plug these in, so I'm going to do sine of second pi x, and then this one is going to be x to the power of 3 minus 4x. All right, so my window should be from 0 to 2, zoom 0. I'll let that graph in the background, but for part A, I know that this is going to be the integral from 0 to 2 of, you can't say y minus y, so I'm going to have to say the top function minus the bottom function. By the way, this top function is sine.
Because it's wave shaped.
It's a wavy shape, yep. And then, well, I mean, the bottom is a wavy shape too.
But it's more of a parabola shape.
Yeah, I guess it's more of a parabola. I mean, technically it should be a cubic, but I'm pretty sure this bottom one is, x to the power of 3 minus 4x. I'm like 99% sure. So it's going to be top minus bottom, so it's going to be the sine of pi x. I guess I can write all of it out right here. Sine of pi x, sine pi x, all of that minus this x to the power of 3 minus 4x. Parentheses do matter in this case because otherwise I need to distribute the negative if there were no parentheses. All of this thing, dx, our calculator will find that for us. It's going to be approximated. It might be exactly. There's the same function. So I'm going to do, let's get out of that second quit. I'm going to do math 9 to calculate the area between my vars right, enter 1, my y1 function, minus my vars right, enter 2, all that common with respect to x, comma from 0, comma to 2, enter, and 4. Oh, okay, it's not approximately, it is exactly, let's go to that, it is exactly equal to 4. Cool beans. Questions on part A?
Do we have to be units? Probably not. There.
I don't think there are, yeah. It's always an important thing to check, though, yeah. Part B, the horizontal line. Again, horizontal means like this. Horizontal line, y equals -2. So let's go ahead and graph that so we can picture what's going on. Y equals -2 is right there. Y equals -2 splits the region R into 2 parts, right, but do not evaluate an integral expression for the area of part R that is below the horizontal line. So it's kind of key, below this horizontal line.
Oh,
Do you lose points if you evaluated it?
No, you don't, because you wrote it first, right? All right, so notice that this line only intersects the x cubed, the cubic function, so we don't have to worry about the sine function at all. So in order to find that area, I'm just doing top minus bottom. Top is that yellow line. That yellow line was y equals -2. So top minus bottom is -2 minus this x cubed minus 4x. It's that straightforward. So it's going to be that, oh, it's not that straightforward because what is that bound? What is that bound? It's an ugly number, I bet. So we need to come on our calculator. Let's go ahead.
Do we need to find that bound?
I think so.
Because we need to evaluate, right, but not evaluate, yeah.
Okay.
Yeah, so I'm going to not graph the sine function because I don't care about you. I am going to graph -2 here, and again I'm going to do zoom 0. I know it's going to be not perfectly great because it would be nice to have our bounds.
My guess for the first intersection would be like around 0.5.
Yeah, that's a good guess. So I'm going to go second trace to calculate the intersection, so 5. Enter, enter. My guess is, yeah, we'll use Rochelle's guess, 0.5. 0.539 is what I got. So it's going to be the integral of 0.539, and I'm going to do second trace 5, enter, enter, and I'm going to guess about 1.5, and it is about 1.675. 1.675. And of course it's going to be top minus bottom, so it's going to be -2 minus, and then I'm going to do this in parentheses, x to the power of 3 minus 4x. All of this thing with respect to x, so dx. And we don't have to evaluate that. I mean, we could. It would be really easy to, but we don't need to. Questions? Rochelle, questions? Good. All right. Do you want me to pause because we're writing it down, or should I just continue? Continue on to part C. All right. So the region R is the base of the solid, so the base now looks like R. Each cross-section is perpendicular to the x-axis. Pause. Even before you talked about a square, if it's perpendicular to the x-axis, everything is written in terms of
X.
x.
Really?
If it's perpendicular to the y-axis, everything is written in terms of
Y-axis.
in terms of y, exactly. So I'm going to write here everything in terms of x. Everything in terms of x. In terms of x. And we're talking about squares. Rochelle's favorite, squares. And we're going to find the volume. We're actually finding the volume, so we need to get the integral set up and the volume set up. If it's a square, is that to the power of 2 on the inside or the outside?
Outside. And there's a pi.
It's on the outside. There's no pi because it's a square, because there's no rotation.
Pi.
Oh my.
What?
I said that.
Okay. Yeah, we're all correct. We're all on the same page. So we're going to have this integral of the same bounds from 0 to 2, and it's going to be,
Would it be the same one as A because with the square root of outside?
Yeah.
it's the same thing as a with a, square.
Power two, sorry.
Yeah, so sine of pi x
I tried to take it different.
minus x to the power of 3 minus 4x, all of that in parentheses. Okay, this whole thing needs to be squared because this is the length of the side of a square, dx. And I need to find its volume. And this is a calculator, which makes it really straightforward. So if I go to Math 9, and it's going to be y1. So I'm going to start my parentheses already. So start my parentheses. It's going to be y1 minus y2. And again, it doesn't matter the order of these because it's going to be squared. I'll either get a negative or a positive. So it's going to be var's right, enter 1, minus var's right, enter 2. End the parentheses, say that to the power of 2. Okay, that's the integrand. And with respect to x, comma, from 0, comma, to 2, enter. And we get our answer, which is 9.978. 9.978. Ask me questions. Looks solid? Alright. It's weird. I haven't messed up so far, or that bad, I guess. I'm like doing pretty good without looking at notes. So now we're saying that R is a small pond, which, I mean, someone is clearly very artistic. It kind of looks like the Twitter logo. That's what I'm visualizing.
Oh, yeah.
So someone was like, well, that's as close as we can get to the Twitter logo. We'll
Or
make
the
a lake.
Nike swoosh after eating like 10 pounds of donuts.
So our Twitter bird got really fat
Just eat it.
and was bought by Nike. All right, so
Wait, what was that by Nike?
Twitter, because it's Twitter and Nike together.
Oh,
Oh, yeah.
No, yeah, totally joke. Okay, at all points in R, at a distance x from the y-axis, the depth of water is given by this. So think of this as like the shallow end of the pool, and it gets deeper and deeper and deeper, and then it's super deep over here. So that's what's happening. Well, maybe, because it's given by this function. So it's actually not exactly true, because it's negative x, so it's probably going to get really, really shallow at 3. So it's actually the deepest over here, I believe. It'll get really, really shallow over here. But anyway, it's talking about depth of the pool. To find depth, you're using this function. I need to find the volume of the water. Well, I need to multiply area by depth. And depth is here. I have a formula for area. Multiply that formula for area times this formula for depth. And I have volume. Take the integral. Done. Are you ready? Set. Go. All right, it's going to be integral from 0 to 2. Bounds have not changed. The only bounds changed were in part B because it was weird intersection. Okay, our formula for area, we're writing it so many times here, it's sine of pi x, that thing, minus x to the power of 3 minus 4x. All right, I'm going to put square brackets around that thing. This thing represents area. I'm now going to multiply area by depth. So this thing time, and I can just write h of x because I can be lazy. H of x does mean something very specific. Or I could be not lazy. It's about the same amount of work as saying 3 minus x. Now I'm going to do curly braces.
For once, we're usually lazy.
Mathematicians and programmers, we're usually lazy. I guess programmers are more lazy than mathematicians. Lazier than
Bill Gates
mathematicians.
says he always tries to find a lazy person to do a really difficult task because a lazy person will find an easy way of doing it.
Yeah, there's a really cool story that I would love to talk about lazy people solving really cool problems, but it's a story for another time. I can probably tell it in 5 minutes. Find the volume of the water. That is the volume if I plug it into my calculator. So here we go. It's going to be math 9. It's going to be, I'm going to start parentheses here. So it's going to be parentheses, and it's going to be vars right, enter 1, minus vars right, enter 2. So that's our area. I'm going to multiply that by 3 minus x. All right, and that is my entire formula with respect to x from 0 to 2. Hit enter, and bada bing, bada boom. Ooh, really? I guess it was a very shallow.
Well, how do you know that the 3 minus x is on the inside of the integral?
How do you know it's not what?
How do you know that the 3 minus x is on the inside of the integral?
Because any function has to be on the inside. Yeah, so I guess our pool is really shallow. On average, it had something less than 1 because actually not less than 1 because it's probably about 2 because our area was 4 and the total volume is 8, which means the depth average was about 2 point something.
Seems about right.
Yeah, I mean, doesn't look like we made too big of an error. So our answer here is 8.370.
How about we just made no error?
Maybe we made no error. It can happen. Dreams do come true. I'm assuming I got this correct. Are there questions? Hopefully I'm not teaching you incorrect things. Let's go on to number 1. How do I do number 1? Well, the limit to infinity, that's top-bottom rules.
So that's gonna be the biggest, power.
Power, yeah, and exactly. So the biggest power here, I'm going to just figure what that is. So it's negative x and 2x. I'm going to multiply those two together. Forget everything else. Negative x times 2x is a negative 2x squared. And then forget everything else. And then on the bottom, it's going to be x times x will be the largest exponent. So that's going to be x squared. And then forget everything else. So when I simplify that, I can kind of just cross off those x squareds, reduce them, and it's just negative 2. Most people will make a mistake on this one because they'll forget that it's a negative x right here, and they'll put positive 2. That is the distractor, I guess. Is that what they call them? Distractors, detractor, red herring, yeah, those things. So don't choose C, it's B. Questions on A, or questions on 1?
Well, it's kind of hard when it says when in doubt, give up and choose C.
Ben, Claire, you guys just ruined everything. And was Aaron in that class too?
Yeah,
Isn't
I
it
was.
usually like,
You were.
isn't it like give up and choose B?
Yeah.
All right, x to the negative 2 dx. I don't like fractions, so let's make them negative powers. Do I need Taxman?
No.
No, you always need to think about taxman when you're going backwards, but we don't need it in this case.
Why don't you need it?
Someone else answer. Go.
Because in front of the X, it's a Y.
That's not the reason. Well, I mean, if there were parentheses here, then you're correct. So if there's like 2x in parentheses, then you're right. Yeah. Yeah, I mean, the inner. If I had to choose an inner, I would say that the inner is x. You always have to identify your inner.
And realize this,
Ugh.
even if we did tax, it would have been like 1 over like negative like 2x to the power of 3 or something.
Yeah. It'd be hard to solve.
You might be paying the taxman with a variable rate. Okay, so it's not taxman, which means I simply just add a power and then divide down. Divide by -1 is the same thing as multiplying by -1 plus c. There it is, d. Questions? Questions. Get your hot questions here. And number 3. I need to do the derivative. Oh, there are 2 different things here, which means
1d2 plus 2d1.
there it is. 1d2 plus 2d1, product rule. So 1 is going to be this thing, 2 is going to be this thing. So 1 is just x minus 1. d2 is the derivative of this thing. It has a doubter and a dinner and no dinner in there. So the doubter is 3 times x squared plus 2 to the power of 2. And then the dinner is 2x. Whew, okay, all of this thing right here was d2. Now let's add 2. I know, it was doubter and dinner. Don't forget your dinner, you will starve. Number 2, part 2 is x squared plus 2 to the power, that looks like a z. That looks like a better 2. All this to the power of 3. That was 2. Then I'm going to multiply that by d1, which is just 1. Cool. And then I have to do some simplifying. Notice that none of these really have pluses. They're all multiplying something. So what is the greatest common factor? I see an x squared plus 2 to the power of 2 in both of these terms. So I'm going to factor out an x squared plus 2 to the power of 2. And then what's left over? I still have an x minus 1. I have a 3. I have a 2x. So I have a 6x times x minus 1. And I also have nothing. Whenever you factor out and you have nothing, you are actually left with a 1. I'm looking for this thing. Does this thing exist?
You actually have, that's actually still x squared plus 2 to the 1.
Oh, you are totally correct. I didn't factor out everything because this is power of 3, this is power of 2. I didn't factor out everything, so it's still x squared plus 2 to the power of 1. Thank you, Ben. Log it. Teacher error. Yeah, okay, so from here, we need to simplify a little bit to get into one of these cases. You can tell that it's going to be probably C or D. Oh, it might be E, I guess, if they did something weird, because I see an x. Okay, maybe not. I still have an x squared plus 2 to the power of 2 in each of them. So forget him. He's not important. This is the thing I want to care about. So distributing this, I have a 6x squared minus 6x plus x squared plus 2. Simplifying that gives 7x squared minus 6x plus 2. Hey, look at that. Part D. Our answer is D. I'll change that to a different color. Just color coding each step. Cool. By the by, I wanted to show you the statistics for these problems. If I come over here to my stats folder, we can look at last year's stats also if we need to, but
Wait, can I see those? It's really
2019, no calculator, which is what we're currently on. These were the stats. So we just did problem number 1, 2, and 3, right? So on problem 1, 2, and 3 last year, 57 got correct, 28 and 14. Oh, so number 3, a lot of people got that one wrong. Everyone put B on number 3. So on number 3, a lot of people put this answer for whatever reason. But the answer is D. I hope we have that correct. Yes, the answer is D. And then this year, 2019, only Ben got number 3 correct. Someone got number 2 correct, and everyone got number 1 correct. Yes. Cool. All right, we're on number 4. How did we do this year on number 4? This year, only one person missed number 4. You might know who you are, you might not. You could probably just look at your final. How to do this integral. So this is going to be taxman twice. Why am I using taxman?
Because there's a number bigger than 1 next to the
Yeah, check that inner. And then inner is 2x, which means dinner is not 1. So u is going to be 2x. Taxman. For both of these is going to be 1, and then u prime is going to be 2, which means I'm paying taxman with 1/2. I'm paying taxman here, and I'm paying taxman here, because I'm distributing this integral twice, so I have really 2 integrals. Alright, so I have the integral, I guess 1/2 if I'm paying taxman, 1/2 of the integral of sine of 2x plus 1/2 integral of cosine of 2x. I'm being informal, I'm not putting a dx. You don't need to be formal on the multiple choice. From there, anti-same is changed, so it's going to be negative cosine of 2x. Don't forget your 1/2, so we'll put a negative, divide by 2, sure, that works. Anti-change is same, so this is going to be plus 1/2 sine of 2x. Where's my answer? These ones are all 2. These are the halves. This one has the correct negative. Good? Cool. We actually got through that video with 12 minutes to spare. You guys have the second page to do. I will be working on that while you are working on it to get that answer key up.